Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. I hurt myself there. Today's very easy puzzle is called Diamond in the Snow 1 by Second Blue. And here are the rules. We have standard Sudoku rules apply, which means in every cell in this grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Snowmen are 1 cell wide and 2 cells tall. The base of the snowman is a larger number than its head. Snowmen cannot be orthogonally adjacent to hot digits, which are 7, 8, and 9. Otherwise, they will melt. Snowmen also cannot contain the hot digits 7, 8, and 9. So what does it mean to be orthogonally adjacent to? It just means that basically they can't share an edge with a 7, 8, or 9. So snowmen can never share an edge with a 7, 8, or 9. So these can never be 7, 8, or 9 here, which is, I guess, hence the diamond in the snow. So this digit is always larger than this digit because the base is always larger than its head. And it cannot contain 7, 8, 9 in the snowman and in the cells that share an edge with any cell of the snowman. So this could be something like, say, 6 and 1, and that would be valid. And as long as these are not 7, 8, or 9, then this would be a valid use of the snowman. So that's about the snowman rule set. We have Dutch whisper lines, where consecutive digits along an orange Dutch whisper line must be at least 4 apart in value. And so as an example, say this was a 3. This would have to be a 7, 8, or 9, because the digits which are 4 or more away from 3 are specifically 7, 8, and 9. And that's the reason why that works. And that's an example of how Dutch whisper lines, or as I'm going to be calling them, whisper 4 lines. And again, this is not something I created. Someone else came up with this idea. I thought it was brilliant, and I use it because it's very extendable. That's really the reason why I use it. So I'm calling them whisper 4 lines because it's very easily extensible. And that's an example of how whisper 4 lines or Dutch whisper lines work. We also have killer cages, where digits in a cage cannot repeat and sum to the clue given. So, for example, these 3 digits must add up to 24, these 3 must add up to 13, these 2 must add up to 15, etc., etc. So, as an example, if this were, say, a 6, this would have to be a 9 here, because these 2 digits must add up to 15. And finally, we have x's, where digits separated by an x sum to 10. Not all x's are given. So, for example, if this were, say, a 3, this would have to be a 7, because these 2 digits must add up to 10, because there's an x in between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. So, first things first, I'm going to mark the digits next to a snowman as blue to start with. So these are all blue. These are, and the snowman itself, because they cannot contain the hot number, right? These are all blue. These are all blue here, and these are all blue here. This must be all blue here. And this must be all blue here. So we know in certain cases where are the hot numbers have to be, right? In this lower left-hand box, we have 6 blue numbers, which are the digits 1 through 6, guaranteed. So these must be the hot digits here. This is 7, 8, and 9. Same with column 4. We have all hot digits there because 6 digits already in column 4 are blue. We have another 6 blue in column 3, so this is hot. To add up to 24, you have 3 hot digits, so these are also blue. Therefore, in the central box, where are the red cells? They have to be here. So this is red. This is blue then. This must be blue. To add up to 10, only one of them can be 7, 8, or 9, right? Because 7 and 8, at minimum, add up to 15. So to add up to 10, one of these is going to have to be blue, which means the other 2 are guaranteed to be red. Well, we have 3 red guaranteed in row 1, which means the rest of the row are not red, so they're blue here. That means in this upper right-hand box, we have 6 blue cells, so this must not be blue. This is red. And this is blue, which must add up with a red, guaranteed to add up to 15. We have 6 blue cells in row 7, which eliminates blue cells in the rest of the row, so this must be red. We have 6 blue cells in column 7, so this must be red here. To be 4 or more away from red, you cannot be red. So this can't be red, this is blue. 1 through 6, right? Because 7, 8, and 9 cannot be next to each other on a whisper 4 line. 1, 2, 3, 4, 5. We can only have up to, in column 1, we can only have 2 more red cells at most. But in this left central box, we need 3 red cells. So since 2 of them can only be here, this must be red here. We have 3 red cells in row 4, so this can't be red. This is blue, which forces both of these to be red because we have blue cells in the remaining digits. Therefore, we have 3 red cells in column 1, so this can't be red, this is blue. This digit, again, we have 5 blue cells in this right central box. We have to have 2 more red cells. They obviously cannot be 4 or more away from each other, so therefore they must be both here. So this is red, and this is blue. We now have 2 red cells in column 9. So this cannot be 2 red cells here. One of them is red, the other one is blue. We're not sure which is which. Same with this. This is blue and red in some sort of scenario. We have 3 reds in row 2, so this can't be red. This is blue. And therefore, we have 6 blues already in this upper left-hand box, so this must be red. Okay, so now we go about finishing things. To add up to 15 with only 1 red, it has to be 6 and 9. So this is 6 and 9. This same, therefore, has to also be 6 and 9. This must then be 7 or 8. This is 7 or 8 with 2 or 3 to add up to 10. These are 3 cold or non-7, 8, 9 digits. So the highest digit here is 6. You could have 6, 4, 3 or 6, 5, 2. Can you ever have a 5 here? No. So you're guaranteed a 6 here. So this has to be 6. These 2 digits add up to 10, and they cannot contain 7, 8, and 9, so this must be 4, 6 pair. But again, this can't be 6 because we are guaranteed a 6 in this cage to add up to 13. So this is 4, this is 6. This can no longer be 3, 4, 6. It must be 2, 5, and 6 here, which eliminates 2, 5, 6 in the rest of the column. So this is 1, 3, 4. This has to be 1 and 3 because of the remaining digits in this box. This then is a 2, 5 pair, and the smaller one has to be in the top. So this is 2, this is 5. This is 1, 3, and 4 here. This has to be 2, 5, and 6 here because of the 1, 3, 4 triplet here. 2 cannot be next to 1, 3, or 4. So this, and this can't be 6. So this has to be 5 or 6 here. The only digits which are 4 or more away from each other in 2, 5, and 6 are 6 and 2. So this is 6, this is 2, this is 5. 2 cannot be 4 or more away from 2 or 5, so this is 6 here, which means this can't be 6 here. 6 can only be next to 1 and 2 on a Whisper 4 line, so this must be 1. This can't be 1. This 6 forces this to be a 1 here. This can't be 1. 1 can only be next to 5 or 6 for digits that are from 1 through 6. And this can't be 6 because of 6 in the row, so this is 5. Let's see, what other digits do we have? Remaining digits in that are blue in column 3 have to be 2, 3, 4, and 6. 6 can't be here. 6 can't be here because of 6 in the rows, and 6 is going to be the highest digit possible out of the blues. So this must be 6 here. This is then 2, 3, 4, 2, 3, 4, and 2, 3, 4. This is a low digit, so it's 2, 3, or 4 here, which forces this to be, this has to be high digit, though, to add up to it. So this is 7 or 8. So it's 2, 3, and 7, 8. This is obviously 7, 8, 9, so this is 7 or 8 here. This is 7 or 8 here. This is 7, 8 pair here. Where is the 9 in this left central box? It has to be here. So this is 9, which eliminates 9 here. Where is the 9 in this right central box? It can only be here. So this is 9. This is 7 or 8 here. Where is 9 in the middle box then? Can't be here, can't be here, so it has to be here. This, again, we don't know what this is. This has to be 7, 8, or 9 here. This is 9 here because the remaining digits in column 7 cannot be 9. So this is 9, which means this can't be 9, this can't be 9. Where's the 9 in column 6? It has to be there. Okay. We don't know where the 9 is here or here. Okay, so 9 has to be one of these two digits here. This is 7 or 8. This is 7 or 8 because of the 7, 8 pair in the row, but this can't be 7 or 8. This is 9 here. So we can start marking the 7 and 8s as different digits. So we're going to make this A here, and this will be B. So that forces this to be A, this is B, this is A, this is B, this is A, this is B, this is A, B, A, B. This can't be A, so that's B, which makes that A. We don't know what these are. This is B and 9. This is A and B here. We don't know. So this A adds up to 10 with this digit and this digit. So these two digits are the same. So this is the A equivalent for 2 and 3. We don't know which it is, though. Oh, this digit must be smaller than that, so this is 4, this is 3. Um, hmm. That means, so this pair adds up to 10. This pair adds up to 10. And these, so therefore these two are the same digit. So let's mark that as Z. Well, where is Z in column 8? It must be one of these 3 cells. Where is A in column 8? It must be one of these 3 cells. So we're guaranteed a Z or A has to be next to the X here, which means that this must be A and Z adding up to 10. So this cannot be A here. So this has to be A here, and this must be Z. Because again, one of A and Z is next to the X. That means both of them have to be next to the X because they're the only ones that add up to 10 with each other. So this is not blue, this is red. So this can't be A, this is B. Oops, I don't know what happened there. This is B, which forces this to be A. That means this can't be A or B. This is 9, and this must be a B. We have 3 red cells in row 8, which eliminates red cells in the rest of the row. This can't be red. This is blue. This can't be blue. This is red. That means this can't be red here. This 9 eliminates 9 here. So this is 6. That's 9. So we have A and B segregated. We have Z kind of set, I guess. Okay. Where is 6 in this upper right-hand box? Cannot be here because of 6 in the column. Can't be here or here because 6 in the row, so it must be here. So this is 6. Where is 6 in this right central box? Cannot be here because of 6 in the columns. Can't be here because of 6 in the row, so this must be 6 here. We have 8 6s. We know where the last 6 has to be. It has to be there. Okay. Remaining digits are 2, 3, and 4. Okay, so this digit can only be 5 or 3. Because it's yeah, this is 3 or 5, this is 3 or 5. Where is That means this digit must be 1, 2, or 4. Well, that's already given. Remaining digits in column 7. Let's do remaining digits in column. Well, this can't be 5 or 6. So this could be 2, 3, or 4 here. This has to be 1 or 3 here to be less than 2, 3, or 4. This digit can't be 6. It could be 2 through 5, which makes this 1 through 4. This can't be 4 because of 4 in the row. We have all the 6s figured out. Do we have anything else? Not particularly. This digit is 4 away from 9 and 7 or 8. So this is 1 through 4 here. Okay. Okay. B has to be next to 1, 3, or 4. We don't have that much information about B though. Remaining digits in row 2 are 1, 2, and 4. Okay. 5 has to be one of these two digits here. That doesn't tell us very much. Do we have anything else? Not really. I guess kind of the question is, can we get to a contradiction here? Right. We do have information here. Where is the 5 in this upper right-hand box? Can't be here, but can't be here. Actually, this 5 eliminates 5 here. So there we go. So this is 3, which eliminates 3 here. This is 5. That means where is the 5 in this right central box? Cannot be here. Can't be any of these cells, so this must be 5 here, which eliminates 5 here. So that's 2, which eliminates 2 here. So that's 5. That means this can't be 2 here. This 3 eliminates 3 here, so this is 1. This can't be 1 or 3, so this can't be 1 here. So we have 3, 4, and 5 remaining in row 8. Okay. Remaining digits in column 1. We have 2, 4, and 5 remaining. Where is 5 in row 4? Cannot be any of these cells because of 5's in the boxes. Can't be here because of 5 in the column, so this must be 5 here. Therefore, this cannot be 5 here. This is 2, 4 as a pair, which eliminates 2, 4 in the rest of the box. So this can't be 2 or 4, it's 3. This can't be 3 or 4, it's 5. 3 means Z cannot be 3. Z has to be a 2. So Z is 2, A is 8, and B is 7. So 2 eliminates 2 here, so this is 4 and 2. So this can't be 4, 3, it's 1, which means this can't be 1, and it cannot be 4, because that's not 4 or more away from 7. So this must be 3, which makes this 4. This can't be 4, 5, it's 3. This can't be 2, 3, or 4, it's 5. That 3 eliminates 3 here, so it's 1. This can't be 2 or 3, it's 4. This can't be 3 or 4, it's 2. None of these can be 2. The only digits remaining in this upper left-hand box are 2 and 4. This can't be 2 because of 2 in the row, so this is 4, this is 2. So no 2 here, no 2 here, no 2 here. This can't be 4 because 4 is not 4 or more away from 7. We have a 1, 3, 1, 3 pair in row 4, which eliminates 1, 3 in the rest of the row, so this must be 4. And this 1 eliminates 1 here, so that's 3. 4 eliminates 4 here, so that's 1 and 4. That leaves this digit as a 3. 3 eliminates 3 here, that's 3 in the corner. We celebrate because we know we're close to solving it, which makes this 3, which makes this 1, which makes this 3. That leaves this as a 4 and this as a 1. And that's a solution to this puzzle. Yeah, fairly straightforward. Interesting sort of new rule set. I've never run into it before, so it's an interesting spin on this. There have been other rules which are similar to it, but this is a nice little sort of thematic one, which works pretty well. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.